Hi everyone, thank you for joining. Today we are going to be talking about Java Web Application Security. My name is Jeff Williams. I'm the co-founder and CTO at Contrast Security. I've been working in application security for almost 20 years. I used to head up OWASP and I wrote the OWASP Top 10. And today I want to show you a new way of thinking about application security. We're going to look at securing web applications and APIs. We're going to do it with some new technology, so it's only going to take a few minutes, and we're going to do it for free, seriously. So let's jump into it. First, I want to start by telling you a little bit about just how vulnerable Java web apps and APIs are. If you think of this iceberg as your typical web application, the stuff below the waterline is all your libraries and frameworks. That's about 79% of your total code base. And then the stuff above the waterline is your custom code. Now, if you look at how this lays out, most of the vulnerabilities are in your custom code. There's a few vulnerabilities in your libraries. But the thing that jumps out is that most of your libraries are actually not even used. They're just along for the ride. So I want you to focus on where your vulnerabilities really are. You need some technology to help you find those vulnerabilities quickly and accurately. The other piece is that you've got to know that your applications are actually being attacked. This is some data that we've collected from about 10,000 applications of various types. And what you see here is in 1 month, over half of the applications have been attacked with typical attack techniques like SQL injection and path traversal and reflected XSS. We also see a lot of attacks on known vulnerabilities. Like this CVE 5638 is the CVE, the library problem that caused Equifax so much trouble last year. And on down the list. So the attacks are out there. You probably have vulnerabilities. So that's a very dangerous situation for folks to be in. So today I want to talk about an approach towards dealing with that problem. We see it in 3 parts. We see that you have to do something different in development. I think the right way there is to get feedback directly to developers through the tools and process that they're already using. It's got to be accurate, and it's got to be in real time. Anytime you delay that feedback or make it inaccurate, development teams just can't use it. So the goal there is to eliminate most of the vulnerabilities early in the life cycle. Some people call that shifting left. And the idea is, let's get clean code out of development and checked in. Now, that doesn't mean we should give up on doing security later in the process too. We want to be sure that the things that we put into production have been checked for security. So we need to do something in our QA and test environment. Here, we don't want to slow down builds. We want accurate feedback, and we want to potentially break the build. If a vulnerability has snuck through out of development and made it into QA test region, then we might want to break the build in order to make sure it gets fixed before it goes into production. And then the last piece is in production. We have to change our game here. Most organizations have no idea who's attacking them or how they're attacking, what techniques they're using. They don't know which URLs and which apps are being targeted. That's a very dangerous situation. So we want to get awareness of those attacks, and we also want to be able to prevent those attacks from actually exploiting vulnerabilities so that we're safe. Even if we have vulnerabilities in production, we want to be safe. This is at the high level what we want to achieve at each of these 3 stages. We're going to empower developers, assure our QA and test as we deploy, and we're going to protect in production. So how do we do that? I mean, that sounds great, but realistically, how do we do that? Well, today I want to tell you about a very exciting offer that my company is making. We've created what we call Contrast Community Edition. It's our product's IAST and RASP engine, and I'll explain what those terms mean in just a second. We've made a free version that anybody can sign up for and use on one application. It's for Java right now. We're going to add our other languages coming soon, but so it's for Java right now. And it's got a ton of integrations available, and I'll show you how those work to enable the kind of process that I just talked about. Ultimately, when you take a step back and look at the world, the situation that we're in, There's 21 million developers in the world, but only 6% of them have access to any kind of decent security tools. So it's not shocking that we continue to repeat the same mistakes and that the OWASP top 10 hasn't changed since I wrote the first version in 2002. So we've got to do something different. Let me tell you how Contrast works. Contrast Security Platform works a lot like AppDynamics or New Relic. The way those tools work for performance, Contrast works for security. So here you can see the Contrast agent. Basically what you do is you download it just like an APM tool. You add that agent to your application environment. So you add it in development and in QA and in production. Essentially you make it part of your application. And what that agent does is it uses what we call deep security instrumentation to instrument the application across all the layers of your app, not just your custom code, but all the way down through libraries and frameworks and app server and runtime. And it provides three key capabilities. First, it adds the ability to assess the application for vulnerabilities. So as you use your application normally during development and QA, Contrast is there looking for vulnerabilities. This is an extremely accurate way of finding vulnerabilities, as we'll see in just a second. And essentially, it's combining the best of SAST and static analysis and dynamic analysis and something called IAST, or interactive application security testing, into a single engine that just deploys as part of in the background as you're doing your normal work. The platform also includes Contrast Protect, which is runtime application self-protection. That capability, again, works in the background. You'll never know it's there except when someone tries to attack your application. It jumps into action and prevents vulnerabilities from being exploited. So even if your application has SQL injection flaws or cross-site scripting flaws or XXE or untrusted deserialization problems, Contrast intervenes and prevents those vulnerabilities from being exploited, whether they're in custom code or in libraries. So that's very powerful. And then the last piece is the open source piece. Contrast also analyzes all of your open source. It tells you exactly where you have vulnerabilities. And it also makes those libraries safe so you can continue to operate even with libraries that have known vulnerabilities. Then you don't have to have a fire drill to replace them. So that's the overview of the platform. We'll take a look at exactly how it works in just a second. I wanted to drill in for just a second and give you a sense of what the instrumentation actually does. So the first step is when you add the Contrast agent to your application, it does that deep security instrumentation. That means it puts sensors on security critical methods like HTTP get parameter or runtime.exec or SQL statement.execute. It also instruments things like data flow and control flow. It looks at the libraries. We actually analyze all the code as it loads. So there's sort of sensors on the bytecode loading process. And it analyzes the configuration as well. That's what we put sensors on because that's what you need to look at in order to find vulnerabilities. So let's imagine that an attacker attacks our application. They send in a SQL injection attack like single tick or 1 = 1. And that attack flows through the application. Well, as that data, that malicious data, flows through your logic, it will hit a bunch of sensors along the way. It may get transformed, it may get split into pieces or combined with other data, and eventually it'll end up in a SQL query that's about to be sent to the database. At that point, Contrast will see that untrusted data has made it into the query, and it'll analyze that query to see, did that untrusted data modify the meaning of the query? If it did, then we know that an attacker has succeeded and found a vulnerability in our application, and we prevent that query from going to the database. So Contrast only blocks things that are confirmed attacks that we see, that we know are going to do something malicious in the database. Now, it works similarly in development. In this case, you're just a normal developer. You're not attacking the application. You're just putting in normal test data, like, say, the word Jeff. Well, Contrast traces all the data from those requests, headers and cookies and parameters. It traces them all. We'll trace this one Jeff through the application, and eventually it gets to a SQL query. Contrast at this point checks to see, hey, was that data ever properly escaped or parameterized in a way that would have prevented SQL injection? If it was, then we don't report anything. But if we've confirmed that this is an exploitable path through the application, then we intervene and we report that this is a vulnerability that could be exploited by an attacker. So we've confirmed that this is a real vulnerability. That's why contrast is so accurate, is it uses the actual application to measure security directly, as opposed to trying to build a complex model of an application and infer vulnerabilities, or try to guess whether something's vulnerable by the way that it responds to HTTP requests. We're measuring it directly from within the running application. So what we're going to do today is we're going to add security to a DevOps pipeline. So I've got Spring Pet Clinic here as a sample application. It's a Spring Boot application that uses Hibernate. It's in GitHub. You can git clone it and do this yourself if you like. And I've got some development tools set up that I like to use on this. We're going to try those. The pipeline that I've got set up here uses Jenkins to build this. We've got some test suites with Selenium and JUnit. We're using Jacoco to measure code coverage. And we're going to pump issues into SonarQube and JIRA. And then as we go forward into production, we're going to deploy the application, and we're going to use tools like Splunk and maybe VictorOps to report vulnerabilities to the people, attacks to the people that need to know about them. So what we're going to do is, so that's a basic pipeline. What we're going to do is we're going to add security to this. So we're going to add contrast in development, and we're going to get instant feedback through the tools that we're already using on vulnerabilities. Then in the QA environment, we're going to just do our normal test processes, and we're going to get vulnerability feedback through different tools, through JIRA and Sonar and so on. And then when we move to production, now we're going to shift gears a little bit. We're going to be detecting attacks. We're going to be reporting those attacks through into Splunk. So that's a great way of turning a DevOps pipeline into a DevSecOps pipeline. Notice that we didn't really add any extra steps. We didn't have to change the process. There's no extra time delay anywhere here. We're just transforming a DevOps pipeline into a DevSecOps pipeline. So let's take a look. We're going to start in the development environment, and I just want to pull this down a little bit. So in the dev environment, I've labeled these environments so that you can see what we're doing. So this is dev. This will be our CI/CD environment, and then we've got a production environment. So we're going to get to those in just a second. But this is development, and there's a few screens, so I wanted to make sure it wasn't too confusing. So in this environment, the first thing that we would do to get started with contrast is we would sign up for the community edition of contrast. So there's a link here that I'll show you. This shows the link that you go to. It's contrastsecurity.com/CE, and it only takes a second to sign up. I'll show it to you here. And you can just go here, create free account, sign up, and you'll instantly get an invitation. You can sign up, and then you'll get your own dashboard that looks just like this. And the first thing that you're going to want to do is add agent. This is just exactly how you get started with APM tools like New Relic or AppDynamics. So here, we're just going to use the Java agent here. You can download it. It's a couple of megabytes. We'll keep it. And now we've got our contrast.jar file. Now what we're going to do with that is we're going to add it to our Spring Pet Clinic project. I've got it set up here, and I took a shortcut. I've already got my contrast.jar in this project. You can put it in the project, or you can put it anywhere on your disk. The only thing that you have to do is find your Spring Boot in your POM and add this Java agent flag. Now you can add this Java agent flag to however you launch Java. Contrast will work on all kinds of applications. It'll work on apps running in any kind of app server, from Glassfish to WebSphere to WebLogic to whatever. You can add it basically to anything that's using Java. This is a standard JVM flag, and we're just using it the exact normal way. So once you do this, your application is now protected. It'll find its own vulnerabilities and report them to you, and it'll also prevent attacks against this application. It's just that simple. So let's take a look here. So once I've done this, I want to just run the application. I actually have it running here. You can see the console as the app started. And when I go to my browser here, just using a browser inside the IDE for convenience, but you don't have to. I can just browse around this application, and here I'll put in webinar and hit go. And you just use the application the normal way. You can see I'm already getting alerts here of vulnerabilities that are coming in, because Contrast, unlike your traditional scanners, works in real time. So just as I'm just browsing around and entering normal data, Contrast is hard at work finding vulnerabilities. And this is really the key, is Contrast doesn't require you to know anything about security. Even novice developers can use this to find vulnerabilities. And that's ultimately the key to scalability and speed. If you can find your own vulnerabilities and check in clean code, then you can sail through the rest of the pipeline and go straight into production. Now, we've done a lot already. We've just browsed around a few pages here, but let's find out what it looks like in Contrast. So when I go back to my Contrast dashboard, now when I pull up this list, it says, oh, there's a new application that was just onboarded called Spring Pet Clinic. So I can click into that, and I can get a bunch of details about how this application works. You can see I've got found 132 libraries. We've got a ton of code. Most of it is libraries. There's only 3,000 lines of custom code. And we've got 3 different servers. I'll tell you about the other servers. There's one in QA and test and one in production. And we've started to build a picture of what this application looks like. You can see in development, we've already found 7 vulnerabilities. We don't have anything in QA yet, so we'll get to that in just a second. Now let's drill into these vulnerabilities. Contrast has found a number of things. You can see the critical down here at the bottom is Hibernate injection. We've also found some problems with the HTTP, like forms that don't have clickjacking protection, and forms without autocomplete, parameter pollution. We also see cross-site scripting. This is a stored cross-site scripting, which is kind of tricky for other tools to find. And cross-site request forgery, another tool that's difficult for other tools to find. Let's take a look at this Hibernate injection and get a sense of what we're really doing. So this is actually quite a powerful page. What this shows is all the details related to this vulnerability. You can see we've created a great title. You've got the dates, a unique ID for tracking. We've got we started a timeline so we can see what happens to this vulnerability over time. And remember, Contrast isn't a scanner. It runs continuously. So we expect to find the same vulnerability over and over and over until it gets fixed. So you'll never have to take 2 different scan reports and try to compare them. Contrast only keeps one version of this application, of this vulnerability. And let's go down here to the details here. I'm going to zoom in so you can definitely read this. This tells a story of this vulnerability. It says, Contrast tracked some data from the HTTP request. You can see that string I typed here with exclamation points. It's encoded. That data flowed through the application, ended up going through this line of code in this method, and ended up in this Hibernate query without having gone through any kind of parameterization or escaping that would have prevented injection. So we know that this is an exploitable path, and you can see it. This is kind of the pattern for SQL injection, is untrusted data flows through and ends itself up in a query without any kind of protection. So with almost no work, we found a pretty serious vulnerability. This one has a fairly easy to understand path. And Contrast shows you all the details. You can see the exact line of code where this data came into the application. This is the get parameter values call. You can see what string operations happened to that string as it flowed through the application. We can open this, it's collapsed for conciseness, but you can open this up and see exactly what happened. We appended this untrusted data to a template query, and then we added the final apostrophe on this line of code. And then at the end here, you can see the line of code that sent this query to the database. And if I open this up, I can see all the state and the full stack trace for this point in the code, all the way down to the container run. So this is really incredibly powerful. It says exactly what happened with this vulnerability, and it's measured it directly from the running application, so we know that it's accurate. In addition, Contrast has full remediation advice. So we tell you the best ways to avoid this problem or fix it if you have to fix it. We've got different techniques with code samples on how to fix these things. There's also the full HTTP request, so you have a test case if you want to replay this. You can. And I showed you the details. So there's really a ton of interesting information about this vulnerability here that makes it easy to go fix. You can also mark this vulnerability as confirmed or not a problem. Contrast is extremely accurate, but occasionally we do have a false positive. Not like the other tools where a large proportion of the vulnerabilities reported are false positives. But Contrast is quite accurate, but every once in a while we have a false positive. So you can mark it as not a problem, and we encourage you to report that as a bug. If Contrast is reporting a false positive, let us know so that we can fix it. Now I'll just detour here for a second and talk a little bit about accuracy. If accuracy is a concern, and it really should be for application security tools, because anytime your tools are inaccurate, you're going to need an expert to come in and resolve it. Whether there's a false positive or a false negative, you're going to have an expert involved. And having an expert involved means that your pipeline all of a sudden screeches to a halt. You're going to have to go find that person. Probably they're already overbooked. You're going to have to wait for them. It's going to take a long time. It's going to break your process. So accuracy is critical. I encourage you to measure the accuracy of your tools, and OWASP has an interesting project to do this. These guys created about 3,000 test cases, and half of them are false positives, half of them are true positives, and they measure which kinds of vulnerabilities the tools are good at detecting, accurate at detecting. And what you can see is, the static analysis tools are, they're kind of all over the place. The best scores are in the 40s and 50s here. Some of them are much worse than that. It just shows that this approach that we're using of getting inside the running application is much more effective at finding vulnerabilities. If we drill down into the contrast results, you can see we finished in about 30 seconds and we scored almost 100%. We have a disagreement with the OWASP team about the definition of this path traversal vulnerability. We don't think these test cases are accurate, but as you can see, we do quite well against this. I'd strongly encourage you to measure this so that you know what your tools are good at. That way you can choose them more effectively. Now this score doesn't mean that we are perfect. I want to emphasize that. This is a very easy test. They're all open source and freely reproducible, so I encourage you to clone this, run the test, look at the tests so you can see and understand them. But this is easy stuff. So it's not that we never have issues, but we can certainly handle the easy stuff better than these tools. Now, let's get back to contrast. So we can consume these vulnerabilities in a number of ways. Contrast has a ton of integrations. So one of the key integrations is right into Eclipse. And here you can see, I'm going to refresh this and pull down the information. We just found these new vulnerabilities, like this Hibernate injection, for instance. And we can dig into this. We get all the same information that we were just looking at, the overview and the how to fix and all the events. And we can even see all the details of this. And for any of the details, we can jump right to the line of code where the problem is. so that we can make the appropriate fix. And here you can see very easily that's the line of code that's vulnerable to injection. So this is one powerful way of consuming contrast results. Now, it's not the only way of consuming contrast results. We also support right in the browser. We have a Chrome plugin here that you can see. And when you click on this, the plugin queries the team server and pulls down the appropriate vulnerabilities right into the browser. So if you're a developer, you can quickly see exactly what vulnerabilities are associated with this page in the application. At this point, I also want to point out a plugin called retire.js. I strongly encourage you to get this. What this does is it analyzes all the open source JavaScript libraries that you're using, and it will tell you exactly what version that you're using and whether there's any known vulnerabilities in it. This is probably the #1 thing you can do to help fight DOM XSS, which is sort of a specific kind of cross-site scripting. So I encourage you to keep your browser libraries up to date. Now this is a nice way to do it. Okay, so what we've done in development here is we've very quickly found a broad range of vulnerabilities. And actually, let me just pull up the range of vulnerabilities that Contrast can find. I'm just going to scroll through this quickly, but you'll get an idea that we can cover a very broad range of vulnerabilities in your application. It's not just injection, although we're fantastic at injection. It's configuration problems and HTTP problems and other kinds of issues. Contrast is there looking at all of it in real time as you code. So I think we've enabled our developers now to write secure code and check in clean code in the first place. Very powerful. Okay, so let's shift here to libraries. This is server-side libraries we're talking about now. And Contrast automatically identifies all the server-side libraries associated with an application. Here you can see some of the ones that are in Spring Pet Clinic, and you can see the exact version I'm using of each of these. So this is version 1.13. The latest is version 2.10, and you can see how much of that library is actually used. That's really powerful. Remember, most libraries aren't used at all, and so you don't want to waste time replacing libraries that are never invoked. So Contrast helps focus you on the ones that are actually vulnerable. And you can drill into any of these and see exactly what vulnerabilities are associated with this library. This is a Jackson library. It's got 5 vulnerabilities. I can track this instantly to exactly what applications it's in and what servers it's running on. So this is quite powerful. And if a new vulnerability comes out, like let's say there's some researchers out there and they find a problem in some library that we're using, I could pull it up very quickly. So I'll just type in, Guava here. I can pull that up. I can see whether I'm using it, and I can drill into it and see exactly what's going on with it. So this is a very powerful capability without any scanning. Remember, all of this has happened with no scanning. This just happens in the background. So everything in my dashboard here for my application is always up to date. It's very powerful. Now let's switch to the test environment. What I'm going to do here is I'm going to launch my test cases. So these run in the background. I can run them either locally on my machine, or I could go to Jenkins and I could just start a build. So when I click build here, now there's a build running in the background and all my test cases run. And Contrast is there in the background, watching all those test cases run, watching all the activity, and identifying any vulnerabilities that are associated with this application. So this is a super automated way of doing security to make sure that every time you check in code, it gets checked for security. So while those run, let me take a detour here and look at our JIRA integration. So with Contrast CE, you can hook it up to your JIRA and get bidirectional JIRA integration. So by the way, you'll see vulnerabilities start to pop up on the screen because they're running, and the test cases are running in the background. So what that means is, I think you should do security a little more formally in your CI/CD environment. If a vulnerability has snuck through development and made it into CI/CD, then probably you want to treat it a little more formally. Make a ticket, make sure it gets closed before you push to production. So having a great JIRA integration helps. You can see this is that Hibernate injection we were looking at. We've got all the details here so that the developer never has to go outside their tools. They can just look at the ticket, make the fix, test to verify that they fixed it correctly, and then check in clean code that then goes into production. So this is a powerful way of working through bug trackers. And there's support for a number of different kinds of bug trackers. Another thing that I like to do is measure code coverage. I use a tool called JIRA here, and you can see if you look closely in my palm, if I scroll down here, you'll see I added contrast to my test run. You can see this is the Surefire plugin. And you can see I added contrast, but I also added JIRA to generate some output. And then I just consume that in SonarQube. So here you can see my test coverage. And this is a nice way of making sure that I not only got good QA test coverage, but I also got great security test coverage. And I can drill down into any of these and see the exact coverage of which methods got hit. And look, here's a method that never really got exercised as part of my test suite. So I might want to write some additional tests. This is a fast way towards making sure that you've got great security coverage over all your applications. Okay, so now after I've spent this time, I'm just going to refresh my application here. And what we should see now is that in just a few minutes, we've got a really well-populated security dashboard. We've got a picture of what's going on in development. Like we're making mistakes in development. That's fine. We're finding them so we can fix them early. But we've got a number of vulnerabilities that have snuck through and made it into our QA environment. And that's really a problem. Or maybe it's more of an opportunity. That's how you can shift left and save lots of time and money by fixing these problems earlier in development when they're inexpensive, rather than later in the process when you have to track them and fix them and retest them and fail compliance checks and all that. So I think this is a really powerful way of thinking about your process, is actually measuring security in development, QA, and also in production. So with that, let's move to production. And so we're going to shift gears a little bit here. We're going to look at actually how this works. Oh, you know what I should do? Let's go back to development for just a second. We're going to pull up that same app where we're not using Contrast Protect, and we're going to exploit this vulnerability. So this simple page here is the one where we've got that Hibernate vulnerability, and you can see it works normally unless I put in an attack. So I'll just put in a simple or 1 = 1 kind of attack, and you can see I just pulled all the data out of the database. That's pretty dangerous. When I go into production, actually if we look at this screen, you can see I'm not using Protect in Develop. I am using Protect in QA, and I'm using only Protect in production. You can manage all that, by the way, on the Servers tab here. You can set up exactly which servers you want to run Contrast on, and so on. Now, in production here, let's go and do that same attack and see what happens. So again, just works normally. You'll never notice Contrast is there unless you attack it. And when Contrast sees this attack, it intervenes. It says, hey, there was an attack. I need to prevent that query from going to the database. Now, Contrast just stopped that. It basically threw an exception inside that database call. And then this application happens to catch the message from that exception and put it on the screen. Most applications don't do that. They would log that exception and sort of continue. But it's important that the application just uses its own error handling and rolls back that transaction and keeps the integrity of the application. So we don't do anything to change any of that. This message just comes from the exception itself. So now this application is protected. I can't force it to to exploit any vulnerabilities. Let's take a look at what that looks like in Splunk. So all this data, we're seeing lots of attacks. And if you start measuring, you will see that your applications are being attacked much more than you think they are. All that data, it goes into the Contrast team server. If you don't have Splunk, you can also send it right into Splunk or some other SIEM tool. And here's sort of the results. I can see all the attacks that were ineffective. These are just the nonsense attacks that are probes against your application. They never connect with the real vulnerability, and you don't have to do anything about them. There's also all the blocked attacks here. These are attempts to exploit you that actually reached the corresponding vulnerability. So these are the ones that you really care about. And then we do have this little slice of exploited vulnerabilities. Let me explain that. That means that contrast was put into log mode. Instead of intervening and stopping these attacks, for this application, contrast was configured to just log. And so it allowed this exploit to happen, and it reported it as exploited. So if you see this, you probably want to turn on protect. Now, of course, you can break this data down. You can focus on what applications are being attacked, what types of attacks are being used. You can see here, XSS is often one of the leaders. We see path traversal, usually one of the leaders, command injection, and then a smattering of different CVEs are the most common things. You can measure attack traffic over time by type. You can even see which URLs are targeted the most across your enterprise. So a lot of details. This is in the Contrast Splunk plugin. But you can also view this data directly in the Contrast dashboard. So I'm going to move this out to the last 30 days and give you a sense of what's going on. Here's a bunch of attacks against my applications. I can see, here there's a bunch of SQL injection and so on. And I can drill down into these events. And I can see, different attacks. Here's one that was pretty recent. We can see exactly what happened. We can see the query string here. We see the attack encoded, flowed through the application, and landed in this SQL query. Obviously, the attacker was able to exploit this, except for contrast, intervened and prevented it from reaching the database. We have a ton of details about this. So a WAF could only sort of see this top line and just have to decide whether that's an attack. That's quite difficult. Because we have the full SQL query, we can do much, much more. We also have the full stack trace, so we can see the context of how this was being used. We have the full HTTP request, so that you can see exactly the details. We can even tell things like the currently logged in user. And that's really useful if you want to block an attacker. Maybe it's better to disable that account that was being used rather than blocking a whole IP address, which the attacker could just move to another IP address or something. So this way you can get a little closer to the attacker. I recommend using Contrast Protect on applications that aren't public-facing, as well as so internal applications as well as external-facing applications. Many internal applications are pretty easy to exploit, and all it takes is one internal desktop machine getting knocked over for an attacker to attack all the internal applications. So it's important that those applications are protected as well. It would be difficult to do that with a WAF, but with Contrast Protect, you can add that to applications inside the firewall as well. So there's a number of other things in Contrast Protect that are interesting. I'm going to go to the Policy Management tab here and just give you a sense of how we manage rules. These are the assess rules. I showed you those before. The protect rules, you can apply them to different environments as you like. You can turn them on and off. We want you to be able to manage the rules across all your applications. Most vulnerabilities are covered by these basic rules. Every once in a while, there's a crazy CVE, some kind of novel kind of exploit that nobody's ever seen or heard of before, or it's custom to a particular framework. In those cases, Contrast deploys what we call a CVE shield. This is a custom protection for unusual kinds of vulnerabilities. You can also deploy virtual patches if there's some kind of behavior that you want to block. You can quickly create a virtual patch, like I could say, this parameter with this name has some pattern, or must contain this, and create this rule and push it out to all my applications in parallel. This is a very fast way to protect your applications against new attacks. We do have, for novel kinds of vulnerabilities, like if someone discovers a new vulnerability that no one's ever seen before, we very quickly respond, we'll push out a new rule, and that automatically gets pushed out to your application. We also have a thing called log enhancers, which is kind of neat. If you have applications that aren't doing good security logging, you can use Contrast to add better security logs. You can do that without recompiling the application or redeploying. Contrast can weave those things in right in production. So anyway, those are some things. Contrast also has bot blocking and a number of other features as well. So that was a very high level blast through Contrast. But let's take a look at our dashboard now after just a minute here. In our Contrast CE dashboard, you can see we're starting to get a good picture of what's going on. As I mark vulnerabilities as remediated, I can even manage my remediation time so that over time I can improve and get better at responding to new vulnerabilities. So ultimately, we were trying to empower developers to commit secure code, and we used Contrast Protect to give them instant feedback on their code as they're writing it through the tools that they're already using. We were trying to get good assurance out of our QA and test environment, and so we used Contrast there to turn all of your QA testing into security testing as well. So that's a powerful feedback. And then in production, we wanted insight on who's attacking us and how they're attacking us, and also protection to make sure that any vulnerabilities that are there don't get exploited. We did it all with Contrast, and we did it all fairly quickly. That's why we're saying that you don't have to rely on old generation tools to do application security. With Contrast, anyone can do it. I encourage you to go to the Contrast Community Edition site, get yourself an account, and give it a try. You should be able to quickly see the value that Contrast can assess web apps and APIs for vulnerabilities. And that's actually really an important point. APIs are difficult to analyze with legacy tools like static and dynamic. Contrast handles APIs just like any other kind of application. So that's a great opportunity to use Contrast. Contrast can monitor your open source code, tell you where it's vulnerable, and protect any open source vulnerabilities from being exploited. And you get that runtime application self-protection to protect your applications, even custom code vulnerabilities, from being exploited. You can see a list of sort of all the integrations that come with Contrast. You'll probably see a number of tools that you're using there. So we look forward to having you try Contrast, and please give us feedback. We do this to try to make our technology better and bring better security to the world. So anything you can tell us about how it's working for you is super helpful. So with that, thank you very much.